All right, so for today we're going to do 1.7, which is exponents. I'm a little crooked there, huh? Well, it might just have to stay crooked. Oh well. So our objectives then today are we're going to define exponent, base, and exponential form. You're probably familiar with some of those, or a lot of those. And we're going to work on simplifying and evaluating expressions with integral exponents using the properties of exponents. All right, so first of all, exponential form. We have a number raised to a power, right? So the number is the base. The power is called our exponent. So if we have 10 to the 6th, which number is the base? The 10. Which number is the exponent? The 6. Okay. And do you understand that if we have 6 times 6 times 6, it's equivalent to 6 to the 3rd? Okay, because it's repeated multiplication, whereas like multiplication is repeated addition. We have all these shortcuts. Is that a question or just a stretch? Okay. All right, perfect. So 5 times 5 is equal to 5 squared. Okay. All right. So example 1, write each of the following in exponential form. So how would you write A? 2 times 2 times 2 times 2 times 2 times 2 times 2. 2 to the 7th power? All right, because there's 1, 2, 3, 4, 5, 6, 7 2's. Very nice. How about B? Negative 3 times negative 3 times negative 3 times negative 3. Like this? No.
That's what I was thinking too.
It's partially right. What's wrong with this one?
Will you put a -4?
Nope.
The
It doesn't have parentheses.
It doesn't have parentheses where?
Around the 3.
Okay, the 3 or the negative 3?
The negative 3.
Okay, because the number is negative 3, we have to put parentheses around it. The exponent only applies to what's directly in front of it. So if we had written negative 3 to the 4th, that's equivalent to negative 3 times 3 times 3 times 3.
Yeah.
Okay? Like it does not apply to the negative sign unless there are parentheses. So do not forget that little aspect of it, okay? So that's super important there. All right, very nice. All those tiny little details in math that you have to remember. Okay, so this one says, notice the difference between negative 2 to the 4th and negative 2 to the power of 4. And that's what I just showed you in that other problem. Okay, if you aren't careful with it, you're going to get two different answers. Negative 16 versus a positive 16, which are like, well, it's only a negative sign. Yes, but in algebra, you keep doing a sequence, right, of problems. So that's going to cause you a lot more problems in your answer. So example 2, let's evaluate the following exponential forms. Evaluate means to do what? To solve them, okay? So how will we solve them? 9 to the power of 3. 9 times 9 times 9. So yeah, so I heard you that. 1 times 9 is 729. Very nice. How about B then? I'm running out of room there. Good. So this would be 49, right? Times a positive 49. That's true. All right, so then 49 times 49 was, what did we decide? 2,401. Okay. All right, how about C? I might have to erase there a little bit. Okay.
That's just gonna be -4. Oh, that's gonna be there's gonna be like a negative, then there's gonna be parentheses.
Good.
4 times 4. So
Perfect.
-16.
Excellent. So it's got that negative out front. So it's got the negative, and then inside the parentheses is 4 times 4. So negative 16 is our answer. Excellent. Very easy. I like that you have that perspective. Unlike the last two. Okay, so I'm going to go ahead and erase this and move on up so we can talk about these properties and then reference them in our next question. All right, so we have properties of exponents here. So the product property, the first one. You'll notice here we have x to the power of a times x to the power of b. They both have the same base. Okay, so in order to do this, they have to have the same base. But then notice what happens to our exponents. What did we do with them?
You would add them.
You add them, okay? So you add the exponents. Okay, that's the deal. You're going to add, so even though they're being multiplied, you actually add the exponents. So this would be like x to the second times x to the third. That's going to equal x to the fifth. Okay, because x to the second means x times x. X to the third means x times x times x. Well, how many x's do you have? 5. That's why we add the exponents. Okay, so a little bit of a reason there. Next up, we have the quotient. Quotient means what?
It's like the answer for division.
Quotient is the answer for a division problem. And fractions, you'll see this as a fraction, fractions are division problems. Okay, so we have x to the a power over x to the b power, which is division. So what happened to the exponents? We subtract them. Notice it says that for x not equal to 0. Because if our x is equal to 0, yeah, okay, it's not going to work out there. Okay, so product, we multiply. Quotient, we subtract. Okay, so we subtract the exponents.
Dude, that makes no sense. Like, why would we subtract? Wouldn't it be, why can't we just call it sum problem instead
This,
of quotient? Because the sum is the answer of subtraction, right?
no, the difference is the answer of a subtraction
Difference,
problem.
the difference.
But it's called a quotient property because we're dividing them to start with. But again, like if I take the same principle, like if I take x to the fifth and divide by x cubed. Okay, so if I take this out, that means I have, in my numerator, I have x times x times x times x times x. 5 x's, right? Divided by x cubed, which is x times x times x.
Yeah.
What did we talk about last week with canceling?
That if there's a negative. Wait, wasn't that negative and positive?
No, like just reducing numbers. Like when we were doing multiplication, we had some problems. Like we had 2 tenths times 5 ninths.
Cross cancel?
We can cancel, right? We cancel because they have something in common. The 5 and the 10 both have a 5 in common. So we say, oh, 5 divided by 5 is 1.
Makes a lot of sense. Yeah.
Okay, so here they have an x in common, and an x in common, and an x in common. So they all cancel in the numerator and the denominator. And we're left with how many?
2.
2, because 5 minus 3 is
2.
2. So this is x squared. That's why we can do the subtraction. Okay, is because it's going to cancel. It's really powerful when you think about it. Like, you know these skills. This is why they work. All right, the last one, okay, is this power property. So that's when our exponent, okay, so we have x to the power of a, and it's raised to another power. Okay, so if we had the x squared to the power of 3, what do we do with those exponents? When it just says, oh, this is the same thing as to the power of ab. What's happening?
Oh, so wouldn't you be multiplying?
Yeah, you're multiplying the exponents this time. So this is equal to x to the 2 times 3 power, which is 6. Why did I put 6 to the 6th power? I'm sorry. Then my eraser doesn't want to work. So yeah, this is x to the 6th power. Okay, fantastic. Fantastic. All right, so what happens when you multiply with like bases? So here, 5 squared times 5 cubed. What happens there? Like, what do you do with the exponents? Okay, so you're going to write it, you add exponents. Yep. So this would be 5 to the 5th power. Good. What happens when you divide with like bases?
You subtract the exponent.
You subtract exponents. Perfect.
I'm gonna just write it subtract.
You can, I mean, it's your notes, so it's up to you. All right, so this one, what would you do? Notice it's got some,
Divide.
we could cancel here, and we're left with,
What?
what's our answer? 8 to the 5th?
It'd be 8 to the third power.
Okay, I say. It's 8 to the 3rd after we subtract our exponents. And what happens when you raise an exponential expression to a power?
And you multiply.
Okay, that's when we multiply our exponents. So what would our answer here be? 3 to the 2nd raised to the 4th power.
3 to the 2nd to the 4th.
Mm-hmm. You said it was going to be multiplied, so it's going to be 3, 2 times 4 power, which is 3 to the 8th. Awesome. Very good. Okay, questions about those properties?
Now, what if it's just easier to do 3 to the 2nd or 3 to, because I feel like that'd be a lot easier than doing 3 to the 8th.
But it's not 3 to the 2nd and 3 to the 4th. If you're going to break it down, you need to do 3 to the 2nd, which is 9, and then it's 9 to the 4th power. Does that make sense? And you could do it like that, depending on how you're doing it. That's not it. But right now we're just working on like understanding how this works, because we're going to take this concrete idea and we're going to apply it to an abstract idea, which means you're going to have x to the 5th times x squared, and you're going to have to simplify that and say, oh, that's equal to x to the 7th. Or you're going to have c to the 10th divided by c squared, and you're going to have to simplify that and say, oh, well, that's going to be c to the 8th, because I subtract my exponents.
So, how do we know to subtract again? If it's division?
If it's division, yep, we know that if it's division, we subtract the exponents. If it's multiplication, we add them. And if it's the, like, b cubed to the 5th, that's when we multiply them. So this is b, 3 times 5 is 15. So we're going to take the concrete and move it to the abstract because it's algebra, okay? So, but we want to make sure you understand it first. All right, are we ready for the backside?
And then that power property, if
Mhm.
it's like, how do we know to multiply?
How do we know to multiply? Just like here. So we have an we have this number that has an exponent, and it's raised to another exponent. So that's a power.
So if it's like in parentheses and it's by itself and then there's another one.
Mhm.
Okay.
Mhm. Yep. Good question. All right, then let's clear this and go to the back. I was like, if it'll clear. All right, so example 3, we're going to simplify, and we're going to leave each answer in exponential form. We just want to make sure we understand this, okay? So in A, 5 squared times 5 to the 10th. What's happening? Are we multiplying, dividing, or is it a power raised to a power?
We are adding. Yes.
Okay, but what's happening to these?
They're going to subtract.
No. What operation is right here?
Add is the power.
What is operation is right here?
Multiplication.
Okay, it's multiplication, so we do what? You told me. We add. Okay, so you were right. You just weren't answering the question that I was asking. So we add our exponents. It's 5 to the 12th because it's multiplication. All right, in B, what operation is happening?
Multiplication.
Multiplication, so we do what?
Add.
We add. So it's going to be 3 squared plus 4 plus 9, which equals
15. 3 to the 15th power.
We're good with that? 3 to the 15th?
Yeah.
Okay, so 3 to the 15th. Good. On C, what are we doing? What's happening here?
We would do we'd
So,
subtract.
well, okay, what is happening?
Division.
This is division, so we subtract. So this is going to be 2 to the 4th minus...
Minus 0 because there's no exponent.
Nope.
1? Oh, 1.
1. Okay, when there's no exponent written, it always is a 1. Okay, so that's good to talk about. So that leaves us with what? 2 to the power of 3. Okay. D, what operation is happening?
We would be.
Okay, don't tell me what we do. I'm asking what is happening. I want you to connect these. What operation is happening?
Division.
Division. What do we do?
Subtract.
Subtract.
Oh, yeah.
Okay, it's 10 to the 5th minus 3, which would equal 10 to the power of 2. Okay, so that's it. Like you have to ask your question, what operation, what do I do? What operation, what do I do? Okay, so what operation's happening here on E? No, this is not multiplication. That's what we do. What, because in order to answer these, you got to think, what is happening? Like, is this multiplication, division, or is this a power, 5 to the power of 3, raised to another power?
That's the power.
That's the power. Okay, so this is a power, this 5 to the power of 3, raised to another power. So we multiply. So this is 5 to the power of 3 times 6, which is what? 18. So this is 5 to the power of 18.
I feel like I'm a lot more awake this morning and following.
Good. All right, so F, is it multiplication, division, or power raised to a power? Power raised to a power, so what do?
2 times -3.
We multiply. So it's going to be 7 to the 2 times -3 power.
That'd be -6.
It would. It'd be 7 to the -6th power. And that's okay. You can have a negative power. That's no problem. We'll get to that a little bit later on how we can make those positive. It's very helpful. All right. Then we've got some information here about the quotient property. Okay, it says the quotient property gives meaning to this idea of 1 over x. So, and x to the 0, pardon me, and x to the -1 power. So, if we look at this, the quotient property gives meaning to the expression x to the power of 0 because it says since x squared over x squared, so let me look at that with you, would equal x to the 2 minus 2, right? We're good with that? We just realized that. 2 minus 2 is what? 0. So this is x to the power of 0. If my marker would work there. Okay. So that's x to the power of 0. But also, anything divided by itself is always equal to 1, right? That's why x to the power of 0 equals 1. Because if we had 4 over 4, what does that equal? 1. If we had 17 over 17, what does that equal? 17 over 17 is a fraction. What does that equal? Well, 1. Okay, so we get this x to the power of 0 because we have x squared over x squared, and it has to equal 1. So that's why x to the power of 0 is equal to 1. Okay, so any number to the power of 0, do you guys know that? Any number to the power of 0 is 1. 5 to the power of 0 is 1. 29 to the power of 0 is 1. Okay, good. So that'll be helpful this year. Okay, then the quotient property also gives meaning to exponential expression with negative exponents. Okay, so like, again, I'll kind of walk through this one with you. If we have x squared divided by x cubed, okay, we kind of looked at this earlier. X squared means I have x times x, and then x cubed means I have x times x times x. We talked about some canceling, right? If we have the same thing in the numerator and the denominator, they cancel. So what do I have left in my numerator here? Well, not 0, because I have a number. If I have this divided by x, it's going to be 0. So I always have a 1. So I have a 1 divided by x. Okay. But this would also, okay, like if I look at the math part of this, That's what this x to the negative 1 power is. Because if I do x squared divided by x cubed, and I say, oh, that's x to the 2 minus 3 power, well, that equals x to the negative 1. So x to the negative 1 is actually equal to 1 over x. Those are the same thing. They are equivalent. So they are equivalent. Okay, so those are going to be helpful as we move forward. But that also means if I have a number like this, I can write it this way with a negative exponent either way. Okay. So let's look at example 4. We're going to apply some of this. Evaluate the following exponential forms. All right, so we have negative 2 to the negative 4th power. Negative 2 to the negative 4th power. What do you think about that?
So are we finding the answers this time?
Yes, evaluate means to find the answer.
So for
Okay.
-4, wouldn't we have 4 groups of -4 groups of -4, which would be 4.
Well, we don't have negative 4 groups of negative 4 because we should have negative 2s.
No, sorry, -4 groups of -2.
How do you have negative 4 groups?
Because the exponent is 4, so we would have since there's 2 negatives, it would equal a positive, meaning 2 times 2 times 2 times 2.
Okay, so no. You're so close. All right, so I'm going to erase some of this stuff so we don't have quite as many distractions in this space for me to make some connections for you. Okay, so you are right that in our exponent we have a 4. So we're going to need 4 groups of negative 2. Okay, that's accurate. But I want to draw your attention to this example right here. When it had a negative exponent, what do you notice happened? Right, because it's saying x to the negative 1 is equal to 1 over x. It went positive. What went positive? How did the exponent go positive? Because we changed it to division. Okay, because now I have an x to the power of 1. So there is my exponent, right? But yeah, what happened to it? Huh? Nope, we just moved it to the denominator. That's it. The negative means, right? The negative is simply like that needs to go to the denominator. So instead of having negative 2 times negative 2 times negative 2 times negative 2 as my problem, it needs to be in the denominator with a 1 in the numerator. Okay, the negative means it's in the wrong place. You can have a negative exponent in the denominator, and that will mean to move it to the numerator. Okay, but a negative means we have to move its location. So then in this case, what would this equal? Negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. So what's 4 times 4? 16. So this would equal 1/16. Okay, so B, we have negative 3 to the negative 2 power.
This one doesn't have parentheses.
Good catch, Zane. It does not have parentheses. So it's a negative.
So we would have 2 groups of 3, but with a negative outside the
Good.
parentheses.
We have 2 groups of 3 with a negative outside the parentheses. And I can move that down. I don't know why I didn't line it up a little better there. All right. And what does that negative in the exponent tell you? That it's in the denominator. So we're going to put it in the denominator. Good. So what does this equal? Not negative 9. Negative.
With the exponent, it would be 1 over negative 9.
Okay. So negative 1/9. And you can write that as like negative 1/9 like this. Negative 1 over 9. You could write it as 1 over negative 9. You can put the negative in the middle. Right? All of those are the same.
Yeah.
Does not matter at all. Okay, so however you write it, perfectly fine. But yes, very good. All right, now C, we already have a fraction, and our exponent is in the denominator, and it's a negative exponent. So how many groups of 6 are we going to have? 3 groups of 6, okay. Okay, because our exponent's 3. And so this, it's currently the negatives in the denominator. It's telling us it's in the wrong place, so where should it go? It should move up to the numerator. So this is going to be in the numerator. And so when we have a number, there's nothing left in the denominator, we always just have a 1 there, right? All whole numbers. Okay. So what is 6 times 6 times 6? You both have calculators. It's okay to use them. Close.
206.
Close.
216.
Can you confirm that? Is it 216?
Yep.
Okay. So that one's a positive 216 because our negative exponent was in the denominator, so we had to move those values to the numerator. Okay. Very good.
So that's 216.
Yep, so it's a positive 216. All right, example 5, we get to leave them in exponential form. Okay. So we're going to simplify, not evaluate, simplify, and leave each in positive exponential form. Okay, so again, ask yourself the question, what operation is happening? Multiplication. So what do?
We
Add.
add.
Add the exponents. Good. So negative 9 plus 7, which is going to leave us with 3 to the power of negative 2. Okay, sweet. Except it says leave it in positive exponential form. Does that have a positive exponent? No.
So we got to convert it.
So we got to convert it to a fraction, right? But we can leave it in exponential form. We just have to put this in the right place. Is this going to go in the numerator or the denominator? Denominator. So we can get rid of that negative exponent. So it's going to be 1 over 3 squared.
But how do we know it's supposed to go in the numerator?
If it's positive, then it is.
Yeah.
Yeah, if it's negative, then you got to move it. Good question. Totally guessed there. All right. In B, what operation is happening between these two? Multiplication. So what do? We add them. So it's going to be negative 3 plus negative 2. All right. That gives me 2 to the negative 5. Same signs, right? So this is 2 to the negative 5th. Again, we have this negative exponent. It says I got to have a positive one.
So it would be 2 over negative 5.
Not 2 over negative 5.
2 over 5.
No.
1 over 2 to the 5th power.
There you go. 1 over 2 to the 5th power. You got it. Because it's saying that exponent, the base and the exponent, that whole power, that whole thing moves. All right. C. What operation is happening in C? Division. So what do? With our exponents? Subtract. So we're going to have negative 2 minus negative 3. Good, because we changed that, right, to adding the opposite. So negative 2 plus 3 is just 4 to the power of 1 or 4. Right? I would take either of those. And you don't have a negative exponent. Cha-ching! You just get to leave it there. All right, D. What's happening in D? What operation is happening?
Power.
A power raised to a power. So what do?
Multiply the exponents.
Yes.
We multiply the exponents. Okay, so it's going to be 5 to the negative third time, or negative 3 times 4 power.
Should be 5 to the negative 12. So then it would be 1 over 5 to the negative 12 power.
Okay, if I move it to the denominator, do I keep the...
5 over 12.
Okay, then it's going to be
1 over
5. 1 over 5 to the 12th. That's how I get rid of that negative exponent, is by moving it to the denominator. Good. Yay! Yes, I agree. You guys rocked it. Okay, so let's see. You still got some time to work on, well, 6 minutes.
6 minutes.
Yeah, you got 6 minutes left today. But you guys did a great job.